So good morning again to everybody who's just now joining. We're going to continue along with chemistry this morning. So we're going to talk about compounds and mixtures. But first, I'd like you to think about some starter questions from last week. So the first question is, if sodium has 11 electrons, how many electrons does it have in its innermost electron shell? And the second question is a true or false question asking you to tell me if the period number of an atom tells you how many outer shell electrons it has. So is this true or false? All right, so could I get the starter question polls up, Miss McGinley? Okay, I've got this poll going now. And then once you've answered these two starter questions, if you guys could start thinking about why can't we find substances like sugar or salt on the periodic table of elements? All right, good morning to everybody who is just now joining. I'll give you guys a couple more seconds to answer these questions, and then we're going to go over them together. All right, excellent. So let's go over these answers together. So for this first question, if sodium has 11 electrons, how many electrons does it have in its innermost electron shell? And you guys did so well on this question. Really great job. Most of you guys said that sodium has 2 electrons in its inner shell, and this is correct. So here I've got the diagram showing the electron configuration of sodium. And as you guys will remember, the first electron shell can only ever fit a maximum of 2 electrons. So sodium does have 11 electrons, but it has 2 in its innermost electron shell, 8 in its second electron shell, and then it has 1 outer shell electron. And now for this second question, which was a true or false question, about whether or not the period that an element is in tells you how many outer shell electrons it has. So this one is actually false, because if you guys will remember, the group number of an element actually tells you how many outer shell electrons it has. So sodium is in group 1, so it has 1 outer shell electron. Neon is in group 0, so it has a full outer shell of electrons. Magnesium is in group 2, it's got 2 outer shell electrons. So the group number of an element actually tells you how many outer shell electrons it has. So really great work on those questions. So now, sorry, that's my cat, he's meowing at me. Okay, so this morning I will be leading the webinar, and you can ask any questions that you need to during the webinar in the chat box, and Ms. McGinley and Mr. Lamb will answer those questions. And this webinar will be posted on your Google Classroom along with all the work for this week. So your work for this week will be to complete the Google form quiz as usual, and then you can work on questions in the Google Slides on your Google Classroom. And then you can also watch Miss McGinley's practical video and try out the practical investigation if you'd like to do that instead. So she's made a video for you guys talking about how you could separate out the components of a mixture. So you guys can do an at-home filtration experiment if you'd like to do that instead. So
sorry to interrupt, Miss Yabi, would you be able to make me a co-host again, as I accidentally logged out of Zoom? So I can do that.
Yes.
Thank you.
Co-host.
Also, we have quite a few requests to see the cat, maybe at the end of the webinar.
Yeah, we'll see. He might go to sleep now, but we'll see. Okay, so the lesson objectives. So at the end of today, you guys will be able to identify whether something is a compound, an element, or a mixture. You guys will be able to describe the difference between a solute and a solvent. And you guys will be able to explain why mixtures can be easily separated, but compounds cannot. So the key points from this webinar will be, what is the difference between an element, compound, and a mixture? And then what is a solvent and a solute? Okay. And before we get into these topics, I again wanted to just give you guys a lot of thanks for your great work in science last week. So here are just some diagrams of the electron configurations you drew. And you guys put so much work and effort into this, and it was just really great to see. So thank you for all your hard work in science year 8. But jumping into this week's topic, so compounds and elements. So returning to our thinking question from the starter, why can't we find substances like water or sugar or salt on the periodic table? Well, the answer to that is that these substances are compounds, not elements. So sugar is actually made up of 3 different elements. So it's got carbon, hydrogen, and oxygen. Water, as you guys all know, is H2O, so it's got hydrogen and oxygen. And salt has 2 elements, so sodium and chlorine. So salt is sodium chloride. So we can't find these substances on the periodic table because they're compounds. So just a real quick recap of what an element is. So as we know, an atom is one particle of an element, and an element is made up of just one type of atom. The atoms of some elements like helium don't bond with others and they stay separate. So I have a diagram here of helium gas, and you can see that each of these atoms is staying separate from all the others. But the atoms of other elements like oxygen can be found in pairs. So you can see here that oxygen gas is actually O2. So it's actually oxygen molecules of 2 oxygen atoms that are bonded together. But even though this is oxygen gas has 2 oxygen atoms that are bonded together, it's still an element because it just has one kind of atom. So oxygen gas just has one kind of atom. So oxygen just has oxygen atoms and helium just has helium atoms. So these are elements. What about compounds? So compounds actually consist of atoms of 2 or more elements that are bonded together. So some examples of compounds that you guys are going to be familiar with is carbon dioxide or CO2. So this has 1 carbon atom that's binded to 2 oxygen atoms. And these are chemically joined. And that's important to remember for a compound is that the atoms of the elements are chemically joined to each other. And you've also got water vapor here, so H2O. So again, that's 1 oxygen that's combined with 2 hydrogens. And salt is sodium chloride. So you've got this sort of lattice structure, this 3-dimensional structure of sodium and chlorine that are bonded together. And then some other examples of compounds are sodium bicarbonate, so NaHCO3, which is actually baking soda, magnesium oxide, and a glucose, so C6H12O6, and then again, water vapor, carbon dioxide, and salt. And one thing you guys will notice when you look at these is that they all have a specific formula. So they all have a specific structure. So for example, water vapor is always going to be H2O. So it's never going to have 4 hydrogens and 7 oxygens because then it wouldn't be water anymore. So water molecules always have the same structure, and the same with carbon dioxide. Carbon dioxide is always going to be CO2. So that's important to remember about compounds is that they have a specific structure, and a compound is always like all water molecules are always going to be the same. All carbon dioxide molecules are going to be the same. So compounds always have this specific formula and a specific structure. So now I'd like you guys to answer some questions telling me if you think these 3 diagrams are showing an element or a compound. If I could get those polls up, Miss McGinley. Thank you. Oh, this is actually the first poll. Perfect. So yeah, is helium an element or compound? What about oxygen? And what about water vapor? All right, excellent. A lot of you guys are getting your votes in. That's great. I'll just give 10 more seconds for you guys to finish answering these questions. Perfect. Okay, let's go over the answers to these questions. So starting with the first one, is helium gas an element or a compound? And most of you guys said that helium is an element. And that is indeed the case because helium gas consists of just one kind of atom. So this sample of helium gas just contains helium atoms. So it's an element. What about oxygen? So is oxygen gas an element or a compound? So this one was a little more tricky because this sample shows two atoms of oxygen that are bonded together. But this is actually still an element because it only has oxygen atoms. So again, elements consist of only one type of atom, and this only consists of oxygen atoms. So oxygen gas is also an element. And finally, water vapor. Is this an element or a compound? And again, most of you guys did so well on this question because it is a compound. This is because water vapor consists of molecules that have one oxygen atom that is chemically joined to two hydrogen atoms. So it's H2O, and this is a compound. Perfect. So now on to the next key term of this lesson. So what about compounds and mixtures? So are compounds and mixtures the same? Or are they different? So is water a compound or a mixture? What about coffee and salt? So we talked already about water and salt, and we discussed that these were compounds. But what about coffee? Would that also be a compound, or is that something different? So again, compounds consist of atoms of different elements that are chemically joined together. So here you can see in this sample of in this diagram of a compound, you can see that these are particles that have different atoms that are chemically joined together. But the mixture consists of different substances that are not chemically joined together. So in this diagram of a mixture, you can actually see that there's two different compounds that are in this sample of a mixture. So there's two different compounds that are not chemically joined together. So these components of the mixture could be separated. So it's not a compound, it's a mixture. And a pure substance consists of only one compound or an element. So here you've got a pure substance, which is another key term that you guys will need to know from this webinar. So you've got this sample of helium gas and oxygen gas. These are pure substances because it only consists of one element. But this sample of water vapor is actually also a pure substance because it just contains one kind of compound. But mixtures are not pure substances because mixtures consists of a couple different components that are mixed together. So let's talk about some differences between compounds and mixtures. So let's talk first about the composition of a mixture. So a mixture can have a variable composition. So you can vary the amount of each substance in a mixture. So let's think, for example, about a mixture of some salt and some sugar. You can put 1 teaspoon of salt in a giant box of sugar, or you can put a giant box of salt and 1 teaspoon of sugar. So you can vary the amount of each of the components in the mixture. Whereas in a compound, this has a definite composition. So you can't change the amount of each element in a compound. So like we were saying earlier, if you've got water, that's always going to be H2O. You're never going to have 14 hydrogens with 95 oxygens because that's not going to be water anymore. Water is always going to be H2O. So there's a definite composition to a compound, whereas with a mixture, you can vary the amount of each of the components of a mixture. Also in a mixture, the different substances are not chemically joined together. So if you mix together some salt and some sugar, the molecules aren't going to join together. The sugar and the salt aren't going to combine together. You're still going to have sugar mixed with salt. It's not going to form a new substance. Whereas in a compound, the different elements are chemically joined together. So for example, in water, the hydrogen is chemically joined to the oxygen in each water molecule. And in a mixture, the properties of each of the separate components stay separate. So each substance in the mixture keeps its own properties. So because in a mixture of sugar and salt, the sugar isn't bonding with the salt, they're staying separate. Each of the substances is keeping its own properties. Whereas in a compound, the compound has properties which are different from the elements it contains. So again, let's think about water. So water is a liquid at room temperature, but the two elements that make up water, hydrogen and oxygen, are actually gases at room temperature. So you can see that the compound has different properties of the two elements that combine to make it. And now in a mixture, another property of mixtures is that you can actually separate them out. So each substance can be easily separated from the mixture, and this is because they're not chemically joined together. But in a compound, you can only separate it into its elements using chemical reactions. So again, in a molecule of water, you can't easily separate the hydrogen from the oxygen. You're going to need a chemical reaction to be able to separate out the elements of a compound. And finally, some examples of mixtures would be the air that we breathe. So the air that we breathe, it's got a bunch of different components. So there's oxygen, carbon dioxide, nitrogen, some water vapor. So it's a mixture because it's got a lot of different compounds and elements in it. Seawater is also a mixture because you've got salt, you have water, probably some sand, and a bunch of other components. So the seawater is a mixture. Most rocks are also mixtures because they're made up of a bunch of different compounds that are not chemically joined together. And then some examples of compounds that we were already talking about are water, carbon dioxide, magnesium oxide, and sodium chloride. And again, these compounds consist of atoms of elements that are chemically joined together. All right, so like I was saying earlier, mixtures can be easily separated, whereas compounds cannot. So for example, if you've got a mixture of some kind of candies, you can separate out all the different colors of the candies because it's a mixture and not a compound. So Ms. McGinley has made a video for this week explaining more about how a mixture of water with some different substances in it could be separated out. So you guys can watch her video and do your own practical investigation on the separation of mixtures. So now I have some poll questions for you guys to answer. So are these substances compounds or mixtures? If I could have this next poll up, Ms. McGinley. Perfect, thank you very much. So I'm asking if air, salt, coffee, and water are compounds or mixtures. Great, thank you all for getting your answers in. This is excellent. I'll give you just a little more time to answer before we go over the answers. All right, so let's go over the answers to these questions. So question 1, is air a compound or a mixture? So this question is a little tricky maybe, but air is actually a mixture because like I was saying, air is made up of a bunch of different components. So we're constantly breathing air that has carbon dioxide, has oxygen, it's got a bunch of nitrogen, water vapor, various, pollutants and things like that are constantly in the air around us. So that means that air is a mixture. What about salt? Is salt a compound or a mixture? Like most of you guys said, salt is a compound because salt is actually a compound of sodium and chloride that are chemically joined together. So salt is sodium chloride. What about coffee? Is coffee a compound or a mixture? And you guys did excellent on this question as well. Coffee is actually a mixture because it's a mixture of water and then whatever compounds come from the coffee to give it that nice coffee flavor. So, caffeine and various other compounds that are in the coffee. And finally, is water a compound or a mixture? And again, you guys did so well on this question. Water is a compound because water, pure water, is just H2O. So pure water just contains these water molecules. So it's a compound. Great. So let's move on to another question for you guys to look at. So this is an example of how this topic would be assessed in an exam. So this is a sample exam question that you guys can look at. So I have some particle diagrams here. And I'd like you guys to tell me which of these diagrams is showing a mixture of gases and which is showing a single compound. So if I could have this next question up, Miss McGinley. Great, thank you. All right, excellent. I can see that a lot of you guys are voting. And again, I'll give 15 more seconds for the rest of you guys to get your answers in. All right, great. So let's go over the answers to these together. So really good job again. Question 1 was asking you guys to tell me which of these diagrams shows a mixture of gases. And most of you guys said B, and this is exactly correct because B has 2 different gases. So first, how do we know it's a gas? Well, when we look at the particles, we see that the particles are far apart. So we know that this is a gas. And now it's a mixture of gases because it's got 2 different gases. So here you have your first gas, which is these white circle atoms. And you've got your second gas, which is a black and a gray circle atom that are chemically bonded together. So B shows 2 different gases. So it's a mixture of gases. And then this next question was a little trickier maybe, but which diagram shows a single compound? And the answer to this one is actually D, because remember, a compound consists of 2 or more elements that are chemically joined, right? So which of these shows 2 or more elements that are chemically joined? The answer to that is actually D, because you can see you've got here a bunch of these molecules that are identical to each other, because they have 3 of these white atoms that are chemically bonded to 1 of the black atoms. So D is showing a single compound. So a lot of you guys said A, and A is actually an element because there's just one kind of atom in A. All right, so great job on these questions. The final topic of this morning's webinar is solvents and solutes. So what happens when you dissolve a substance in some kind of liquid? Is it a compound or a mixture? So when you dissolve something, you have a solvent and a solute. So the solute is what you're trying to dissolve, and the solvent is what you're dissolving it in. So for example, if I've got a cup of tea that's bitter and I add in a teaspoon of sugar, my tea is my solvent and my sugar is my solute. So when you're dissolving the sugar in the tea, your solvent molecules surround the solute molecules until your solute is evenly distributed throughout the solvent, making a solution. So this is also shown in this diagram here, where you've got a dilute copper sulfate solution. So you've got some water and some copper sulfate, and then you're adding more copper sulfate that's then dissolving in your solution. So that means that your solvent is your water and your solute is your copper sulfate, because your copper sulfate is being dissolved in the water. So it's being surrounded by the water molecules and it's spreading out evenly throughout to make a solution of the solvent and the solute. So here is a diagram that shows us that a solution is actually a mixture. So in this diagram, you've got some kind of a solid solute that's being dissolved in a liquid. And you can see that the end product is a solution where the solute particles are surrounded by the solvent particles. And it's a mixture because you can see that even though the solute is now evenly spread throughout the solvent, they're not actually chemically joined together. They're still chemically separate. They're just sort of evenly distributed in the solution. So a solution is a mixture. So now a few questions to ask you guys about some everyday examples of solutions around us. So if you have a cup of coffee or a cup of tea and you add some sugar, what's the solvent and what's the solution? And then in a bottle of soda, what's the solute and what's the solvent? In a bottle of soda, you've got some water, and then you have carbon dioxide for the bubbles, you've got some sugar, you've got some flavoring. So what's the solvent and what's the solute? And then also if you add some food coloring to water, what's the solvent and the solute? So if I could have these next polls up, please, Ms. McGinley. Thank you very much. All right, excellent. You guys are getting your answers in, and I'll give you guys plenty of time still to answer these questions before we go over the answers. All right, let's go over the answers to these questions. So for question 1, you put a teaspoon of sugar into a cup of coffee. What is the solute in this situation? And most of you guys said sugar, which is exactly correct. So remember, the solute is the thing that you're dissolving, and the solvent is what it's being dissolved in. So your solute is going to be your sugar because that's what you're dissolving. Question 2 was trickier. So in a bottle of Coca-Cola, there is some water, carbon dioxide, sugar, and flavoring. So what are the solutes? The correct answer was actually sugar, flavoring, and carbon dioxide. So this is a little trickier, but the carbon dioxide is actually also dissolved in the water in your soda. So the carbon dioxide would also be one of your solutes. And finally, you add some food coloring to a glass of water. What is the solvent? And the water is actually the solvent in this situation because the water is what you're dissolving your food coloring in. Great. So now to conclude our webinar, we're just going to have a lightning round where we're going to look at a bunch of these particle diagrams. And I'm going to ask you guys to identify whether these particle diagrams are showing an element, a compound, a mixture, or a pure substance. And some of these diagrams are actually going to fit into more than one category. So you can select all of the options that apply. So let's start with this first one. Is this an element, compound, mixture, or pure substance? If I could have this poll up, Ms. McGinley. Perfect. Thank you. And remember, it might fit into more than one category, so you can select all of the options that you think applies. All right, perfect. So let's go over the answers. So this is an element and a pure substance, actually, because remember, a pure substance is a substance that only has one kind of element or compound, and this only has one element. So it is an element and a pure substance. Perfect. What about this next diagram? What's this showing? Is it an element, compound, mixture, or a pure substance? All right, thank you guys all for voting. That's excellent. All right, so let's go over the answers to this one. So this one is actually a mixture. So this is a mixture of two different compounds, or of a compound and an element, sorry. So you've got an element here and a compound here. And if you've mixed them together, this is a mixture. Great. On to the next one. What's this next one? Element, compound, mixture, or pure substance? You guys are doing great on this question. Excellent. Amazing. So this is a compound, but it's also a pure substance. So if you guys remember, again, a pure substance is something that only has one element or compound, and this is a compound, but it's only one compound, so it's also a pure substance. So that can be a little tricky, but a compound can also be a pure substance. That's an important thing for you guys to remember. Up next is this one. Is this an element, compound, mixture, or pure substance? All right, let's go over the answers to this one. So this one is actually a mixture of two different compounds. So you can see here that you've got two compounds. So it's a mixture. And it's not a pure substance because it's got two different compounds. Great. So for the final question, is this an element, compound, mixture, or pure substance? Amazing. You guys are answering this question really well. Just a few more seconds. All right, perfect. So this is actually an element and a pure substance, because you can see that this here is an element like oxygen, where two of the atoms are combined together to make an oxygen molecule or a molecule of an element. But because it's just one element, because it's just one type of atom, it's still an element. And also because it's just one kind of element, it's a pure substance. So it is an element that is also a pure substance. Great job on these lightning round questions. So that's all the information that we had to cover in this week's webinar. And your work for this week is going to be to complete a Google form quiz as usual. And then you can work on some questions in Google Slides on your Google Classroom. And then you can watch Miss McGinley's practical video on how you can separate out the components of a mixture. And you can try out this investigation at home. And then there's also a summary video that you can watch on compounds and mixtures if you want a quick reminder of the key points from this week's webinar. And that's it for this week. So are there any questions that I can help answer?
Not at the moment. Oh, yes, one. Do you have to do the practical? No, as always, you can do the exam questions instead of the practical.
Yes.
Can we see your cat, or is it sleeping? Is a question that's come in.
Oh, yeah, he went to hide. I'm so sorry, guys.
Sorry, guys. Maybe Miss can include a picture of him in the next webinar.
That's true. I can totally do that.
Right.
All right. Well, if that's everything for this week, thank you guys so much.
One more question. What's the cat called again?
Oh, his name is Buddy.
Buddy.
Mm-hmm.
Good name. So maybe next week you'll get to see a picture of Buddy, guys. We'll try and incorporate him into the lesson somehow. This could be fun.
Yes. Yeah. Or on a video of Buddy doing science, something like that. But great participation this week, you guys. You guys did so well on all these poll questions. But if there's nothing else, then thank you. Sorry?
That's it. Yeah, just people saying bye.
All right. Well, bye. And thank you so much for participating, you guys. And have a great rest of your day. Thank you, guys. Bye.